Okay, this is the second lesson on completing the square. Completing the square is a posh name for writing a quadratic expression in this. Well, we saw it last time with this rather odd, sometimes written with a p, x plus q all squared plus r, or might even say up some minuses in there somewhere. So notice that they use p, q, and r because they're in order, so it could easily be a, b, and c. Don't be surprised if there's a variety of letters. I've seen D's and F's, E's and F's as well. So that's what we're trying to do. We're trying to produce an expression with that kind of funny brackety squared thing. And I did hint last time that the reason we're doing it is because once you know where the vertex is, you can draw the graph. And that's quite important. Well, first of all, a little starter. I want you to have a go at these. These are meant to be multiplying and dividing fractions. And you should know by now that to multiply a fraction, you do top times top, and then bottom times bottom. But it implies you can also divide by fractions. And the way I was always taught it at school is you're not allowed to divide by fractions. But what you are allowed to do, if it says divide, you turn, well, if there's two fractions, you turn the second fraction upside down and you multiply. So that should be a bit upside down and multiply. Now that should be a bit of a clue because essentially these are all over times of divide. Now you've got some algebraic ones there as well, so best of luck. So I'll pause it. I suggest you pause it now, and I'll put up the answers when you're ready. So here's the answers. Hope you got those. I shall leave you to that. If any problems, come and see me. Now, completing the square then. Last time we saw that you are trying to write it in this form, as I said. If you do, you can therefore sketch it from the vertex, and a few other little tricks as well along the way. So I suppose this is my clue. Notice this one, I've deliberately done it for us so that we're not faffing around trying to do it. So it says 4x squared plus 12x minus 5 looks like this. Now, I don't know quite why I've written it because like that, because if I was doing it myself, I wouldn't write 1.5. I suppose it's quite nice in terms of knowing that it is 1.5, but it's much better written as 3 over 2 all squared minus 14. It might be in one of the ones on the previous PowerPoint, I don't know. And it wants me now to sketch this thing. And the key is, once you know that, you can go, plus 3 over 2. This is my first thought, is to look inside the bracket. And because it says plus, a bit like that starter we did the other lesson, it's basically an x squared curve that's gone left. Because it says plus, it goes the wrong way. So it goes to minus 3 over 2. And you take that minus 14 there, and you do exactly what it tells you. It says minus 14, so it's not up here, it goes down here. That's minus 14. And now I know my curve looks like this. It's an x squared graph. And it goes up and up and up, symmetrical as you can. And the other thing I would recommend you look at is not just what this coordinate down here is, which I now know is minus 3 over 2, comma, minus 14. But because the first piece of information has a minus 5 on its own, that's called the y-intercept. So that tells me that is at minus 5. Now, if I draw the posh version of this graph, you can see it drawn for us. You do get asked in exams, not only just to sketch it, sometimes you get asked for details from it. So you might be asked, for instance, where is the vertex? Well, I've already told you, minus 3 over 2 comma minus 14. You might be asked, what's the minimum value? Well, the minimum value is just how far it goes down. And if that's how far it goes down, don't be surprised that the minimum value is y equals minus 14. You also ask what's, not unsurprisingly, called the line of symmetry. There's the line of symmetry. I've drawn it down there. And again, if it was me, I'd write line of symmetry. I'm too lazy to write it here. But I'd write equals minus 3 over 2. But you can see what I've done. I've said x equals minus 1.5. Same thing. And I've even seen that asked. I mean, a bit like this, the minimum value is really trying to get you to say what the vertex information is. But I've even seen that asked by, what is the equation of the normal to the curve at the minimum point? And that answer is x equals minus 1.5. It's the same answer. But they say, well, I should point out, This line going straight across, you see, that line is called the tangent to the curve at its minimum point. The normal is the one that goes at right angles to the tangent, so this effectively is the normal. It's a posh way of saying what's the line of symmetry. And the equation of the normal to the curve at the minimum point is, well, it's the line of symmetry really. X is 1.5. So be aware that there's lots of different ways of asking the same thing. This one says the same thing, by the way, sketch quadratics using completed square form. So this is not very nice. It starts with a 7, it's in the wrong order. So my very first thing I'm going to do is put it in the right order. X squared first, then the 6x, then a plus 7 at the end. Okay, now I don't like the minuses, so I take that out. I did this last time. X squared plus the 6x. And you should recall that we only ever do that trick for the first two items. Plus 7 stays outside the bracket. Now I have to half the 6, which is 3. So it's in brackets x plus 3 all squared. Don't forget now I do 3 squared, which is 9, so I take away the 9. And don't forget the plus 7. Now I write minus the bracket squared. Minus and minus is a plus 9. Plus that 7 sounds to me like plus 16. So it's minus x plus 3 all squared plus 16. So what does that mean it looks like? Well, to me that means it looks like x plus 3 all squared. Well, an x squared graph looks like that. Oh, but notice it's a minus x squared graph. So it looks like that. It's got a plus 3, so I know it goes 3 to the left. So just in your mind say to yourself, this would normally be 3 to the left. There it is. That's at minus 3. It's a U shape, so it's got to go up there really, isn't it? And you also know it crosses that initial 7 without any x's. That's where it crosses there. So you can see this does go up to 16. It comes down. Oh, that's a bit of a dodgy graph, isn't it? Yeah. That would be a better graph. Get rid of that. And you get a line of symmetry down here. This coordinate up here is, what was it? It was minus 3, 16. Let's see what I've got as my picture. There it is. Minus 3, 16. Yes, that looks right. And what information might they say? They may say, where's the vertex? Well, minus 3, 16. They say, it may say, what's the maximum value this time? This is because it's a N shape rather than a U shape. It's got a maximum value up here. What else is it going to have? Well, it might ask for the line of symmetry. Well, hopefully we now know that's at minus 3. Because that's at minus 3 there. We notice we have to say x equals minus 3. And the last one might be some rubbish again. Find the equation of the normal to the curve at the point. Oh, that's x equals minus 3. Here's another one. This is a backward question. It's a bit mean, actually. When I first saw this, I thought, how cool is that? It wants the equation. It doesn't tell me what the equation is. It wants it. Well, this vertex is the key. Notice it's fall that way this time. Well, because it's to the right, I know it's x minus 4 all squared. That's the very first thing I can do. Now, it goes down 3. Getting easy this, minus 3. Now, that could be the curve. But you notice they've got a p here. Now, p could be any number. So I've got to use probably this point here to see if that works. Or maybe even this point here. You know, I've got what on the face of it that should work, but it might not. I want that to work so much, but this is why I said this is a difficult one, because it's a backward one. So let's just try this. Now this point here is the point 0, 29. Now 0, 29 is x, y. So that basically means when x equals 0, y has got to equal 29. And I suppose, let's try it. Let's put x equals 0 into this. 0 minus 4 squared. Now that is 16. So you can see in an instant 16 minus 3 is not going to give me 29. So that is not true. That hasn't worked. So there must be a number here, and they kind of hinted that there is. Let's try a 2. Let's put a 2 in the front. So, and I think this is going to work, you know. Look at this. If I put a 2 at the front, and I randomly picked 2, I didn't know it was going to work. But if I put 2 there, and I put a 2 there, and I do 2 lots of 16, well, 2 lots of 16 is 32. Take away 3 equals 29. That did work. I got the point I wanted. Okay, and that seems to have worked then. So notice the order in which you do this. You can write down the 4 straight away, you can write down the 3, but it's this initial bit. What was the stretch that did it? You might need a bit of trial and error to get the piece of information they give you. They might have given me a point over here. They might have said, when it's 5, it's whatever. Well, fair enough, but I don't know what it is. And I'm going to have to then work out what the value of P is. So that was the right answer. Notice they've written it properly. 2 lots of x minus 4 all squared minus. In fact, I did write it. There you go. Last question. Express this in the form of that. Well, all right. Now, I think that, by the way, is meant to be a square, so I shall get rid of that. So I've got minus 2 plus 6x minus 5x squared. It's in the wrong order, so immediately I'll put it in the right order. Plus 6x minus 2. And I've got to complete the square, because that's what that says. So take out the minus 5 now. Minus 5 both comes out. Oh, it's not very nice, this. X squared plus, what's that? Minus 1.2. That's not very nice. 1.2 would be better written as 6 over 5. Because it's just nicer. X. Don't forget, you only do the first 2 things. We've said that a few times now. So if that's the case, I now need to half this rather yucky expression. It's already 6 over 5. If I do it again, it actually becomes 6 over 10. I double the bottom number. So I get x squared minus 6 over 10 x. Oh, 6 over 10, sorry. I've forgotten what I was doing there. So I take that and the reason why I halved it was so I can write it in this squaredy form. And notice I then have to do 6 over 10 times 6 over 10, which is 36 over 100. Minus 2. Now, multiply this out, it says minus 5. And just see if we can tidy this up a bit. X minus, this is really 3/5. It's much better if I write 3/5. And 36 over 100. In fact, I shall multiply it out at the same time. Minus 5 times that gives me, I think, 36 over 20. Which is the same as 18 over 10. 9 over 5. Getting a bit messy this last example. And don't forget my minus 2. So that equals minus 5 lots of x minus 3/5 all squared. That's like 10/5. That's 9/5. I think minus a fifth. So I don't know if that's right. Let's see if it tells me. Yes, it does. I've got that right. Now it says explain why then this has no real solutions. Oh, I can see why. Because, look, this thing is squared, so I know that that is positive. I'm going to times it by a negative. Well, positive times a negative is a negative, so I know this whole expression is negative, and then I take away another negative. This is always less than 0 for all values of x. So it doesn't matter what number I put into that, it will be negative. So I don't know what it looks like. Well, it's got there. Do I know what it looks like? It's over here somewhere. It's going to do something like this, you know. Oh, that must be minus 2 on my graph. Now, basically, it never ever crosses here. So you get real solutions. You get solutions for quadratics when they cross the axis, and this never does. So that's why it's got no real solutions, and that's my posh version of the answer, but I'm not sure if it's any good. I'll let you read it. And then we're on to exercise 3C. Now we started this already, so you'll notice there's some questions I'm expecting you to do, but not any others. But just see what you can do.